Guys, today we're going to solve this question. Take k of each character from left to right. So basically, what this question tells, let's say we have a string of this. So in this string, the condition is this string basically contains only three characters. It could be A, it could be B, or it could be C. Only these three characters, and we have a value of k. So basically, they want us to have a two pointer. Let's say this is the left pointer and this is the right pointer. So what they want us. So basically, you need to find a minimum array which contains at least k amount of the frequency of the character. So let's say I have an array of let's say 2 comma 2 comma 2. So these are three values in which the first one defines the frequency of A, the second defines the frequency of B, and this one the frequency of C. So we need to find this array. And since the condition says that value of k could be at least, so which means that it could be greater than 2, which means 3. So as you can see right now, we are over here, left pointer. So if I just check the current situation, we can say that the count of A is 1 as well as the count of C is 1. So yeah, so cool. Now if I try to move my left pointer right over here, since I'm right over here, my count of A become 2, and if I try to move my right pointer over here, my count of B become 1. So since the question is already pre-solved, so what they tell us basically the size of the array is 8, which is a minimum length to satisfy the question's condition. So if I put the left pointer over here and if I put my right pointer over here, so this is the array and this is the array. If I take the subarray and count the frequency, this tells us that it is a minimum subarray whose length is 8, which tells that it satisfies the condition. Since the frequency of A is 4 and the frequency of B is 2 and the frequency of C is also 2. So that's the whole question, what us to do. So how can we do this question? So basically, initially I also have no idea how to do it, but after finding out on the solutions, I got to know that we can solve this question by just inversing the logic, which means basically doing a reverse engineering, and we can use a sliding window approach. Yes, we can do by doing a simple sliding window approach. So instead of validating, like we need to find that frequency which satisfies the condition, what we can do, initially we're going to initialize this type of array. Since we could have used map, but you guys going to say that array is more efficient. So let's say initially we have initialized it to 0, but once we did that, we gonna first of all count the overall frequency of all the character. Let's what the frequency of A, as you can see, it is 2, then 4, and then 2, which means basically 8. Frequency of A is 8. Then if I'm going to count the frequency of B, it comes out to be 2, and the frequency of C comes out to be 2. So this is our valid array itself. The length of the valid satisfied condition according to quotient comes out to be right now it is 12. But we don't want 12 to be answered. We want to minimize it as the quotient says. So let's say we assume a window which have left pointer and right pointer right over here. Well, let me just change the color. It's kind of overlapping a lot. So right now, as I'm over here, what I can see, if I'm at this window, which means that I'm going to reduce the count of this by 7, since I have utilized in my window. Still it is going to be a valid window, so I'm gonna store the value of this, and it could be 11. Now, once I try to move my right pointer over here, I'm gonna also take up this A, which means that I'm gonna reduce it, and R will be right over here, and also it's going to reduce to 6. Still, this satisfies a condition, so our length would be 10. It is also the minimum length, but we want more minimum. We can do better. Now, once we reach over here, right at this position, which is B, and my right pointer is over here. So we have also included B, and I can just see that if I do this, it becomes 1, and it is not at least equal to K, which means that it doesn't satisfy the condition. So shall I do this or no, bro? This array just become invalid right now. Let me just change the color again. Let me make it red. Yeah, so this become invalid array. So how can you fix that thing? So we just simply going to move our window right over here, since this window doesn't exist over here. So if this and we're going to move our window right pointer over here. So basically what this tell us that basically this particular portion no longer exists in the window, so we can just put it back right over here. So it will make this thing 8 again, and this will become 2 again, but our window is right over here, so A going to become 7 as this, and this is this. So in this way, we can move up to this, and we will eventually found at a point in which left pointer is over here and the right pointer is over here, in which if we do this, we found out that the frequency of A become 4 and other frequency become 2 and 2. So this is the way. In this way, we will be able to find out the minimum length of the satisfiable condition of the quotient, which comes out to be 8. And also basically how can we calculate A? Basically we're gonna find this value, the length of it is basically 4, and we're gonna subtract it with the total length of the array, which is 12, and its key was the value of 8. So that's how we do the quotient. It is still going to move and going to find going to iterate over until pointer R reaches the end, and that's how we do it. Yeah, so let's guys just code it up. So first of all, what our aim was, our aim basically was to fill up our array of count. So in which it is going to be like this into three, since we have only three character ABC. We're gonna count it from this, let's say for I in string, which is S, and we're gonna do count this. ORD just means that it's ASCII value. We're gonna put C over here and then subtract with ORD of A. So you must be thinking that how this thing is working, how it is giving us the correct, what do we say, index. So I'm going to show a simple example. Let's say if I do, I mean, we know that if A, B, C is like this, we know the difference between this is 1 and the difference between this is 2 and the difference of itself is 0. So let's say assume let's say ask a value of A could be, let's say, I mean, whatever, let it say 96. If I try to do subtract A with A itself, it's gonna give me a difference of 0. But if I do ask a value of B, which is 97, if I subtract with 96, it's gonna give me the index 1. So that's why it satisfies the condition of mapping. So that's how we can do it. If for the C, it is going to be 98, and we do a subtraction with 96, we're gonna get the result of 2. So that's why we have put it right over in this way. So in this way, we'll be able to count the number of frequency of, what do we say, the character, the total count of the character in the string. Then after that, we're gonna check if the minimum of count is less than k, which means that this quotient doesn't satisfy, I mean, the input test case which we have given doesn't satisfy the condition of the quotient. So we're simply going to return -1, as the quotient says, like right over here. If it doesn't satisfy the condition, we're gonna return -1. So yeah, that's it. Now how can we do the main part, since it was just counting the total frequency. Now what we need to do, we're gonna use a sliding window approach. I'm just gonna put it like this, sliding window. So just like a traditional sliding window, we're gonna pick a left pointer right over here, and we're gonna iterate over all over the array. So I'm gonna pick right pointer as like this, and in the range of length of this, what do we say, we have string this. Yeah. So since we have included this pointer right over here, I mean the target value, which is basically, if I do s of r, we have this value right now. So how do I get the index of it? Since I've shown you guys, if I do ORD of this with the value of a, we're gonna get the index, and simply we're gonna do ORD. Basically, we're getting the ASCII value using that same formula, and we're gonna reduce it since we have included in this thing into our window. Again, now we're gonna check that is this thing, which we have done right now, doesn't satisfy the condition, which means that we have encountered a case in which the window is invalid. I mean, window is making the solution, the outer layer side, which means the outer portion invalid. This is the outer portion, which is making it this thing invalid. So how to fix that? Just so to fix that, basically we need to move a left pointer towards the valid area. So we're simply going to move a left pointer like this, L plus 1. Now once we move that thing, we simply know that the L is no longer exist in the window. So what we can do is we can just simply put it back into the account that this frequency doesn't exist in the window, so you can just add it again. So we're just undoing the thing which we just did redo. Yeah. So then plus 1 into it. Then after that, we're gonna just check the result. So we're gonna check the minimum value. So right now I have an initialize the result, which is going to be float of infinity. Now cool. Now what I need to do is I just need to put the result, and like I showed you, which means I need to take the length of it, and we're gonna subtract with the current length, which we have L minus R, I mean R minus L plus 1, since our indexing starts with 0. Then after that I'm gonna return the result, which is res. And let's see, hopefully this code will run. I mean, I still don't know it will run or not. If it does, I mean just luck. Yeah, it worked, and that's how we do it. Yeah, that was a pretty straightforward question, but to get the solution, it was kind of hard. So yeah, it is also optimistic. Yeah, thank you.